So welcome one and all to the first lecture of our Introduction to AI. This overview would basically just go over the definitions of artificial intelligence for this class and help you kind of get started with your first homework assignment. So the kind of historical context of artificial intelligence is basically trying to make machines that act like humans. So one of the kind of the Gothic examples from early 1800s was Frankenstein, where the book by Mary Shelley tried to recreate a human from a dead body as a way to kind of mimic human intelligence, which in the book it does. In the movies, the Frankenstein isn't that smart, but in the book it's pretty smart. The idea was kind of have humans playing God and like making life. That's kind of the idea with AI, maybe not making God, but kind of making computers act like rational human beings. And then kind of an earlier example of this was the automata, they called the Turk. And what the Turk did was it played chess. And it made it seem like it was actually a machine that could learn chess, but in actuality it was kind of a cheat. There was a human, a master chess player, inside the box that would put the chess moves in and make it seem like the Turk was playing chess, but when it actually was just a human playing it. But it tricked a lot of people. And this thing went from the 1780s all the way into the late 1800s as a kind of a Turing example, and it was a huge success. And incidentally, there's a human kind of in the background doing problems business by Amazon called the Amazon Mechanical Turk, where it seems like you basically send really quick programming tasks or really quick tasks to humans. And they act like in the background like they're performing AI, but they're actually just humans in the background. But the Turk was kind of an idea automata in the late 1700s, 1800s. And then also in the early 1800s was another attempt, it was called euphonia, where it was basically using bellows and like mechanisms and even like a mechanical tongue to try to reproduce humans talking. So the idea of trying to make it seem like machines are doing human activities idea's been around for many centuries. And so if you want to get some videos, kind of an idea of what's going on, we're going to have videos in this class like this one. We see that CB2, basically it's like a robot that's a little robot that kind of looks like a child and does human things. There's videos, many videos on it. And then there's also the Virtual Human Research Project, which is basically trying to use software to try to act like humans, and it's actually a toolkit that you can use. And then another example is the Big Dog, which is a project by Boston Dynamics, which makes those like kind of like creepy four-legged walking robots. The Big Dog was one of the earlier ones of this, but you can look at many of the Boston Dynamics videos and see what they're doing with walking around and stuff like that. And so the big question is for this class is, what is AI as discipline? And basically it's basically a discipline that tries to systemize and automate intellectual tasks. So basically what you want to do is get computers to act like humans, think like humans, act rationally, and think rationally. And so this is basically saying, okay, I've come into an area where something's not working, let me take a different approach. And AI is basically the idea to do that. So it kind of builds on, basically you're trying to teach and learn, have the computer teach and learn it for itself. So for acting like humans, this is the art of creating machines that basically does stuff that get computers to do stuff that normally humans can only do. And so this would be something like analyzing a photo, performing some action based on what the humans do. And so the typical example of this is the Turing Test. And what the Turing Test is a way for, if you had a human interacting with a machine, it wouldn't be able to tell that it was a robot. I think it was another human being. And that's what the Turing Test is. And so in 1990, there's the Loebner Prize, which basically gave $100,000 and a gold medal to the first computer that responds indistinguishable from human beings. And I think the $100,000 prize is more token, because if you could do this, your company would be $1 billion company. So the Turing Test has been going on for many, many years. and it's kind of automated to like kind of more like totally represent a human being. So you kind of early kind of tries of the Turing test were chatbots that would go online. I mean, even back in the days with Amazon or with AIM, AOL Instant Messenger, but kind of is building on to that with robotics and so forth. And the next kind of part of AI is think like humans. Requires basically it tries to make processes that kind of act like the neurons and synapses in a brain. You might have heard of neural networks or neuromorphic processing. This is an example of thinking like humans. Basically, we're trying to get processes to think like the brain. Initially, artificial neural networks were trying to match the brain exactly. They found that that's almost impossible. And so what they've been doing is basically using AI or neural networks to kind of perform tasks very quickly and learn, kind of like the brain works, but not exactly. But we're still kind of working on that. Some people that are working with neuromorphics, also known as neural nets, are trying to get the brain to work exactly. But it's really difficult. There's a lot more to the brain than I think all of us understand. And then the other part is think and act rationally. Basically, just given some inputs, signals, snaps, kind of perform like a human would do. Kind of do something that would be rationally performed. So say, for example, for a driving car, if you see a door suddenly open in front of you or a car suddenly pull in front of you, you would weave. That's the idea of thinking and acting rationally. And the basic idea is you don't have full knowledge, you have limited resources, and you see something you don't see, how would you react to that? And then again, performing rationally. This basically, rationality is kind of measuring how well something performs. So, for example, for a car, if a car pulls out in front of you, a self-driving car pulls out in front of you, not hitting the car, would be acting rationally. And then the idea of AI is kind of, basically what we'll do is kind of rational agents. In this case, an agent is an entity that perceives and acts. So basically you have software that perceives the environment it's in and then acts based on that. And this course is going to be mainly focused on designing rational agents. And then kind of an agent is something that, for the definition of this class, something that kind of records or perceives histories and then adapts its actions to it. So it's essentially learning. And for a given, basically we're trying to, for a given environment and a given set of tasks, we try to make an agent that's going to perform the best. So we'll look at different ways of developing agents, and then you will evaluate which one you think will be best for a particular situation. That'll be the core of this class. There will be some programming, but in addition to the programming, you want to analyze how your agents are working and what you could do to maybe make them better. And that's the idea of AI, is just continually developing, continually making better, something actually more like humans. And again, computational limitations and also knowledge limitations make a perfect rationality unachievable. We're striving towards the best capable. And so, as far as the architectural components for AI system, we have a state spacer. So we're going to try to limit the space that you're in and which states, and then also define which states you're going to be working in as well. How are you going to represent the knowledge? So for example, one of the first assignments is going to be a maze. So I'm going to represent the maze as just input data, and then you're going to try to solve the maze. Logical reasoning. So basically these will be the if-then statements of where you're going to go next as far as given a set of input, given some histories, where you want to go next. So how you're going to act on uncertainty. Are you going to keep on searching, or are you going to give up? Stuff like that. And then learning. So basically, given all the stuff before, what we know about the space, how we're going to represent knowledge, the logic, and then what errors you make, how you're going to improve. This is the architecture we'll do for all the assignments in this class. And this is kind of the basic architecture for all AI is you have to kind of limit the area you're going to work in and then try to figure out how to work in it. So there are many fields in AI. On the top I have artificial intelligence. And then I didn't put all of them up here. I kind of just put the ones I first thought of. So my PhD was in computer vision, and so I always have that one up there. And then I also work now currently in neuromorphic processing, essentially neural networks, and then pattern recognition. But there are also fields in natural language processing and knowledge representation. This is an extensive list. It's just kind of a few things I thought of. You might notice I didn't put robotics up here, and that was intentional, mainly because robotics, I feel, is such its own field. It kind of has AI, but also has mechanics in it and all sorts of stuff in it, that control theory and stuff like that, that makes it kind of a multidisciplinary field. Part of it is in AI, so maybe I should have included it up here, but I decided not to. And so, as far as the definition of what fields are included in AI, there's kind of two schools of thought. The first school of thought is basically everything that kind of tries to teach computers to learn and like have a rational space and stuff like that would be AI. So, someone says, "Oh, I'm an AI." Someone says, "Oh, I'm a computer." For example, someone would say, like me, I would say, I'm a computer vision, normative processing, pattern recognition expert. Someone might consider me an AI expert, even though I don't know anything about natural language processing and very little about knowledge representation. But those are all fields under AI, so I'd be considered an AI expert. The second way to also think about it is, and this is the way actually I prescribe to, is once a field branch becomes a field of research on its own. So, for example, now computer vision has its own conferences. You can take grad school classes in it. It becomes no longer a field of AI. AI is only the cutting edge of knowledge like getting computers to act more like humans. So when a field starts getting its own conferences and graduate school classes or undergrad classes, its own field of research, it's no longer part of AI. It's its own field. And generally, that's kind of the way I feel about it. I don't consider myself an AI expert because I don't work in the cutting edge. I kind of more delve into doing applications for existing fields. But on the flip side, I'm not so quoted that when someone talks to me, introduces me as an AI expert at work or at a conference or something like that, I'll just say, yeah, I am. I won't correct them. So it kind of goes the way you want to think. But usually within computer science research, the second definition as AI is kind of whenever it's cutting edge, it's kind of the prevailing definition. However, kind of the public in general, basically they go by the first definition where all the fields kind of fall into AI. And you'll see this, I see this at my work at Raytheon as well, where pretty much anything that's learning based is considered AI. And so for the applied areas of AI, we can think of game playing, so like chess and Go, speech and language processing, expert reasoning, planning and scheduling, computer vision, and robotics. Where AI, like I said before, is a field of robotics. So for playing chess, you need to figure out the environment, so that's your state space, the board, what actions you want to take, so based on what the opponent's doing, what you should do, so legal, and then you're bounded by legal moves. And then, are you doing the right thing? So you're acting rational. Are you going to win, basically? And so games are actually a very good field for AI because they're basically there's all these things are already defined, so it's a good way to go. I work in artificial intelligence for predicting baseball and football games, and sports is also a great example because the rules limit basically all the different probabilities and it makes it a limited space. And then so as far as like expert reasoning, you diagnosing diseases, you have the parents' information. Basically, you also have a little bit more mid, but you only have a certain amount of finite health conditions. You're either from 100% alive to 0%, which means you're dead. And so you can basically use for the environment, use the patient information, results of tests. The actions are basically when you've decided what's going to happen, you look at all the environment, you choose which diseases are, so you have some sort of heuristic, and then you can also, based on the disease, choose what the treatment is. So you know the patient's history, what allergies they have, what treatments they've tried before, and what seems to work. And then see if they're doing the right thing, basically eliminating the disease or making someone better. So there's been a lot of work in making expert systems that diagnose patients. It's having some resistance from the medical community, but that's starting to fade away. And I think basically, from what I've been told, the main prohibitor from doctors isn't so much they're getting replaced by robots, but they're worried about lawsuits where they have a computer make a decision for them, and they and then they get sued if it has a bad outcome. And then driving, which is a lot of popularity. I mean, Uber, Google, Apple, um, all the major car dealerships, like car companies, Ford, Chrysler, and GM, all are working on self-driving cars. So the environment here is a highway. You basically want to drive on the road, and the actions are accelerate, brake, turn, navigate, other controls, and then doing the right thing. Basically, don't get in an accident, get where you want to. And the driving, the main reason why driving has become such a big deal, and this has been going on for about over the past 10 years, is California basically decided not to make any more highways, and so they basically want to do self-driving cars. So you can get basically with self-driving cars, you can get a lot more cars on the road without having traffic congestion. So the idea is to have self-driving cars to basically reduce congestion, and that's basically for the idea for cars, so Ford, Chevy, stuff like that. The car companies. Uber's motivation for it is they want to reduce their labor costs. And basically get rid of their drivers, and so that's why they're pushing self-driving cars, and they have billions and billions of dollars to work on that research. And then for search engines, can you guess what the environment is? It's the World Wide Web. The actions are retrieve documents and get users' queries. So basically, I mean, search engines, they're basically advertising companies, so they want to give you the best results, basically, so you can keep on using the service, and then people get more views, and so they can make more money through advertisements. So basically, a search engine wants you to try to use them more, but also try to stay on the internet as long as possible, finding stuff that you like and you want to see. And so the actions are retrieve relevant documents, and also try to give them predict what documents they want to see next. So you can basically give and predict what ads you want to put in front of them to see if they get the best results. And then basically the doing right thing is getting the people to stay on the internet longer and use their documents, and then in the long run just make more money. And then for recommending, like, so Amazon, use AI. They're going to basically use the store. The actions are recommend items. So what Amazon does is they're pretty clever, and they basically look at based on what your interests are, and then what other people that have the similar interests have been buying. That's how they recommend stuff for you. And so basically, again, they want to increase their bottom line by making more sales. So if you have a relative item, maybe as an alternate, a higher price item that's better quality, or just a complementary item, you buy both of those. And that's what Amazon's basically going for, all the online shopping things. So basically from the AAAI.org, and as well as from the instruction pages, I developed these pages, and also the help of my department head, Li Zhu. Dr. Li Zhu has helped me put together these slides. So hope you enjoyed this presentation, and I hope you guys have a great rest of the afternoon.